Okay, hi everyone. Thank you for the introduction from Professor Levin. Okay, I'm Xiang Hami. Today I will present you our work on residential IP proxy as a dark service. So, as you all know, web proxies are commonly used to anonymize traffic, to evade censorship, or to avoid geolocation limits. Examples include Tor network, VPN, or simple HTTP or SOX proxies. However, those proxies networks have some limitations. They usually have a limited number of exit nodes, and their exit nodes are usually deployed on data center IP addresses, and some of them are even publicly available, such as a list of Tor relays. Also, many users may share the same exit node, so those exit nodes can be heavily abused. As shown in previous study, traffic relayed through those proxy networks can suffer from service blocking or degradation. Recently, some proxy providers started to launch residential IP proxy as a service. Examples include Luminati, JServe, and ProxyRec. They usually claim to have millions of residential IPs, and they said their IPs are very clean and you will never get blocked. Also, their residential IP proxy are globally distributed and there is no traffic limits. So, how it works? What's the scale and the distribution of those residential IP proxies? Are they actually residential ones as claimed by those proxy providers? Also, even if they are residential ones, how effectively can they help to evade traffic detection and blocking? Besides, how can so many residential IP proxies get recruited by those proxy providers? Besides, who are using those proxy services and for what purpose? In our study, we are focused on those important questions, along with other interesting findings, such as the connection between different proxy providers and also the threats to the local network environment. So let's start. How it works. As a customer, to relay your traffic, you will contact the proxy gateways, which will select the exact proxy, residential proxy to exit your traffic. So basically, they work in a back connect model. So the residential IP proxies are actually hiding from the customers. Besides, they usually support HTTP, HTTPS, and also SOX protocol. And multiple different rotating strategies are supported, such as sticky gateways and non-sticky gateways. For sticky gateways, it will stick to the current residential IP proxy for 5 or 10 minutes before switch to a new one. For non-sticky gateways, it will randomly select available residential proxy to relay the incoming traffic flow. Also, some proxy providers even allow customers to decide which location to exit their traffic. You can decide which country. You can decide even which city to exit your traffic. So what's the scale of those residential IP proxies? To understand this question, we set up our web clients, which will send traffic through those residential proxies through our web servers. Through this manner, our web servers can observe the public IP addresses of those residential proxies. One thing to note, each request is identified by a unique subdomain. Also, the payload will be encrypted and signed because we don't want those proxy providers know we are infiltrating them. We then go ahead to purchase 5 popular proxy providers and conduct a large-scale infiltration across different months. Overall, we have sent out more than 60 million successful probers. And those probers allowed us to capture more than 6 million unique IPv4 addresses that are used for relaying traffic. Those residential IP proxies are globally distributed in more than 200 countries and managed by 50K ISPs. Also, they are widely distributed in the network space, as shown in this picture. In this picture, each pixel denotes a /24 IPv4 prefix, and the color of each pixel means the number of residential proxies identified in this /24 prefix. As you can see, they are very widely distributed in the network space. Here, we scale up some small parts to show more details. Okay, millions of residential proxies. Are they actually residential RPs as claimed by those proxy providers? To answer this question, we have built up a residential RP classifier to decide whether the given RP is residential or not. We're starting this process by collecting ground truth from different sources, as shown in this table. As different sources may have different noisy levels, so we use a high confidence ground truth for training, but left the noisy ones for evaluation. We then go to craft a set of features for our classifier. We observed that residential RPs are usually directly assigned by ISP to homeowners. Also, because they are directly managed by ISP, the network hierarchy can be very different from non-residential RPs. Based on those observations, we collected DNS and RP whois dataset to character different properties of those RPs and their prefixes. Finally, we got 35 good features for our classifier. One of them is the number of domains resolved to the /24 RP prefix of a given residential RP proxy. We then compose a balanced ground truth to experiment with different classification algorithms and also tune their parameters. Finally, we select a random forest, and which has achieved a very good performance. We then apply this classifier to predict whether the captured residential RP proxies are actually residential ones. And our prediction shows that almost 6 million of them are residential ones. So for this question, our answer is basically yes. We then go to another question. How effectively can they use traffic detection or blocking? To answer this question, we first explore, will they be recognized as proxy? If they can be recognized as proxy, the server side can still block their traffic or degrade the service. Also, we try to identify if there is malicious activity connected with those residential RP proxies. For the first question, we collect a set of public available proxy data set, such as Tor relays, free web proxies, and also RP2 proxy service. We then correlate with our residential RP proxy dataset. Results show that only a negligible portion of those residential RP proxy were shown up in those public proxy dataset. For the second problem, we collected a set of RP-related threat intelligence and blacklist, such as bottlenecks, spam house, and also some threat intelligence platforms. Correlation shows that only 2% of those residential RP proxies were shown with connection with malicious activities. So basically, we can say those residential RP proxies are highly evasive. So millions of residential RP proxies that are highly evasive. So how can those proxy providers recruit them? It's challenging to answer this question. We're starting from looking up some legitimate recruitment channel provided by those proxy providers. We also conducted RP profiling to understand the device types of those residential RP proxies. Another effort we made is to identify identify proxy programs that are actually relaying traffic in the real world. So for the first part, only Luminati was found to have recruitment channel through its Holo program. However, as shown in previous study, Holo programs are very problematic. They may incur a lot of risk to common users. We then move to profile each captured residential IP proxy. We send probers to grab the network banners for those proxies. And more than 700 RPs responded to our banner grabbing. And more than 500 of them, 500K of them got their device type identified. Here shows the top device type identified in our dataset. Here is the top device vendors. As you can see, we have captured a lot of gateway devices. However, we also capture a lot of IoT devices, such as web cameras, DVR, or even printers. More importantly, we have captured IoT devices for all 5 providers under our study, including Luminati. One thing to note is, while Luminati has Holo program to recruit volunteers, but their Holo program actually don't provide software that can be installed on those IoT devices. So the next step is to identify programs that are actually used to relay traffic. In this step, we got help from our industry partner, which install software on their users' devices. With agreement from their users, they were able to monitor the network traffic of potentially unwanted programs. Through correlation with our infiltration dataset, we were able to identify 67 potentially unwanted programs that are used to relay our infiltration traffic. And those programs covered all 5 proxy providers. Also, when we send those programs to ViceTotal for analysis, 50 of them were labeled as malicious by a lot of antivirus engines. So who are using those residential IP proxies and for what purpose? Still, with help from the same industry partner, we were able to retrieve 5 million traffic flows for those 67 proxy programs. And our analysis for the traffic destination shows that more than 9% of them were reported as malicious by ViceTotal. Here shows the categories reported by ViceTotal. Here are some examples. Also, we manually studied the top 1,000 traffic destinations. Here are the categories of those traffic destinations. As you can see, most of them are ad-related domains and URLs, such as affiliate networks, mobile advertising, or advertising exchange. Others include the search engines, shopping websites, some malicious domains, and also social network websites. So we also identify some other interesting findings. Firstly, we identify the connection between proxy providers. This table shows the overlap of proxy providers in terms of the residential IP proxies captured in their network. One thing to note is a residential IP proxy will be counted as overlap only if this residential IP proxy is captured in both proxy providers in the same hour. Combined with other information, we can conclude that Proxy Online and GeoSurf are actually controlled by the same owner. And IPS is some kind of reseller or customer for Luminati. Besides, we identified that 3 out of 5 providers actually allow local traffic. So what does this mean? Instead of send traffic to our web server, what if we send traffic to the loopback address? It works. What if we send traffic to the private gateway address? It works. So what's the result? Actually, we can get access to the login page of many riders, Wi-Fi devices, and even printers, which means we can try different passwords and then change the writers of those proxy peers. Another finding is the long-tail distribution of those residential IP proxies, as shown in this table in terms of country and ASNs. But the different countries actually have different distribution. As shown for the in the table, they have different top countries. So to summarize, we have captured millions of residential IPs that are highly evasive. Also, this ecosystem is very prosperous, and the service price is getting higher, and more service providers getting out. However, without strict traffic limitation, those kind of services will incur potential threats to the local network environment of the proxy peer. Also, the recruitment process is very problematic. It shows up a mix of legitimate and suspicious channels. What makes us very concerned is, based on the usage of those proxy services, we believe it has become a very powerful infrastructure for online abuse activities. Also, it can be a very promising but very stealthy monetization channel for compromised devices, especially under the hood of legitimate users and volunteers. As we all know, a lie that tells you the half-truth is very powerful and can be one of the darkest lies. Thank you, that's all.
Oh, we have time for questions, if anybody makes their way to the microphone. In the meantime, I'm curious, did you engage with any of these proxy providers to tell them about, I mean, so some of these it sounds like maybe they are the culprits, but have you engaged, for instance, with Illuminati to let them know that, I forget the name of that one provider, seems to be reselling them and this access to localhost?
Yeah, we actually discussed with our collaborator regarding this. But because we found they are a little suspicious, it's not like you find an attack case, then you report to the vendor because you believe the vendor is still on the good side, right? So finally, we decided not to discuss those findings with them. But I still think maybe it's a good idea. Yeah.
Hi, I'm Armin from Avast. Thanks for the great talk. Just like a quick question, is there any way for me as an owner of a residential IP to find out that this IP is participating in one of these proxy networks?
I'm sorry, because a lot of people are opening the door, so
did you find any way that I, as an owner, as a consumer of a residential IP address that lives in my home gateway, is it possible that I find out about that my device is participating in a residential?
Yeah, that's a good question. So your question is basically, can I find my devices on my network is actually participate in those residential proxy services?
Yeah, right.
Right. We are working on some kind of detection methodology for the ISP from the ISP side, for them to detect whether there are suspicious workflows that are highly likely to be residential relaying activities. But by now, I don't know a very good solution for end users or the ISP to accurately identify whether their devices or their network has been used for such kind of activities. We are working for some kind of detection. But one thing to note, as I show in this slide, we have a website where you can find all the 6 million IPs captured in our infiltration. And if you can correlate with your own network to see if there are a lot of IPs captured in your own network. Yeah.
Got it. Thanks.
Another round of applause for Xiaohang. Renaissance.